All right, in this video, we're going to take a look at how to use arrow diagrams to transform functions. We're going to look particularly at the linear parent function here. So what we need to remember about that is what the linear parent function looks like. It's an interesting one because it doesn't actually do anything. So we put a -1 in, we get a -1 out. Put a 0 in, get a 0 out. We put a 1 in, we get a 1 out. Okay, so this is the function that we're going to be transforming. We're going to do that by these four transformations that are listed over here. And I'm going to start out by going through those and identifying which of those are vertical transformations and which are horizontal. So shifting to the left, that is definitely horizontal. Stretching vertically, it says vertical in there, so that's a pretty good clue that that is vertical. Reflecting over the y-axis, since the y-axis looks like that, if I reflect things back and forth over that, they change their horizontal position. So that is a horizontal transformation. And shifting down one, up and down is vertical. So that's a vertical one. So what I'm going to do is take my parent function and attach some arrows. All my horizontal transformations go off to the left here because we're modifying the input. The horizontal axis is the input axis. And my verticals go off this direction because that is modifications to the output. And then I'll just go in order by what I see. So I'm shifting left 2. Left is subtraction. Stretching vertically by a factor of 3. That's multiplication by 3. Reflect over the y-axis. A reflection is a sign change. And shifting down 1, that would be subtraction because down is negative. And now I can actually transform the points that I'm looking at into their new points. I'll start over here on the output side. It says multiply all of those by 3. So I have -3, 0, and 3, and subtract 1 from each of them. That'll put me at -4, -1, and 2. If I shift my attention now over here, then I'll follow the arrows and do what they say to do. -1 subtract 2 is -3. 0 minus 2 is -2, and 1 minus 2 is -1. And then this arrow, this final green arrow, tells me to change the sign on all of those. So that becomes a 3, a 2, and a 1. So these points now, an input of 3 leads to an output of -4, an input of 2 leads to an output of -1, and an input of 1 leads to an output of 2. These are the points that I need to put on my graph. So 3, -4 is right there. 2, -1 is right there. And 1, 2 is right there. My parent function is linear. It's a straight line. These line up in a straight line. So I will do my best here without a ruler to draw a straight line through those points. That's what that graph should look like. Now, before we wrap up and go on here, we're going to go ahead and write what this transform function actually is by starting with an input of x. And we will have to build some roads to go this direction because we didn't have any going that direction. My arrows are all one-way streets. The opposite direction of a sign change is a sign change again, change it back. The opposite or inverse operation to subtracting 2 is adding 2, and now I have paths that will get me all the way back to the other side. I start with my x, I change the sign, add 2, throw some parentheses around that, multiply by 3, and subtract 1. That should be my new function. And if I can do a little distributive property here, -3x plus 6 minus 1 is g of x, or -3x plus 5 is g of x. And that is the equation of my transformed function. And that is how we use arrow diagrams and parent functions to perform transformations.